All right, what's up, guys? So, last video for today. Tomorrow I'll get you the key for the review, but Centripetal Force Lab. So, pre-lab questions here, explain why an object moving at constant speed in a circle is still accelerating. So we've talked about this in class. Changing the direction means changing the velocity, which means you're accelerating. So, because I would expect you to put this in a sentence, but because the direction is constantly changing, that means that velocity is changing and the object is accelerating. And centripetal force directed towards the center. So, ideally, you know that. They made a hypothesis here, so no right or wrong there, just had to make a hypothesis. And then for our data, so what we want to have here is mass. Let's say this is low, medium, and high. And then here, these are the ones you wanted these to be about the same. Length was the same, period was the same. And then, here this lined up, we talked about this in class today, is that those would be low, medium, and high. So it takes more force for the object of more mass. So as mass went up, centripetal force went up. Second part of this for the as we increase the speed, so if period here, this would be, I'll just make up some numbers here. Let's say 5 seconds. That'd be, you must have been spinning it really slow. 10 seconds and 15 seconds. So those aren't practical numbers. You probably had something like 1, 1.5, or 2 or something. But these would have been low, medium, and high. So the faster it was going, I did these backwards. So I made the mistake that a lot of kids make. So this would have been high, medium, and low. So low isn't, so high period means it's going slow. It's taking a long time. So don't confuse those the way I just did, right? And then ideally, your mass was the same and your length was the same. Kids did that just fine. Then here, as length went up, so we'll just call this low, medium, and high. So, since it's length, we'll change this to short, medium, and long. So a short radius is going to be the high force. So the farther away it was, then the lower the force it was. An independent variable here, so this is kind of just a basic science question. So in part 1, it was the mass. That was what you were changing. Part 2 was the speed or the period, and part 3 was the length or the radius. So that was independent variables, what you change, radius. Dependent variables, so this is what we were measuring. So we were measuring the feel, or if you said centripetal force, that's probably the best answer, but we measured the feel for it. And then here, looking at our data, so this is what I just talked about as we went through it. Greater the mass, the greater the centripetal force, greater the velocity, greater the centripetal force, and the greater the radius, the lower the centripetal force. In this lab, what provided the centripetal force? So this was the tension in the string. So some kids answered it that way, which is the correct way. And then other people said, since it was the feel, it was your arm. And that's fine. Your arm was putting a force on the string, which was putting a force on the object. So technically, it's the tension in the string. But if you said your arm, I wasn't overly worried about it. And if you let go of the string, what direction would that travel? So that would travel in a straight line. So remember, it's moving tangent. So the object would fly up in a straight line because of its inertia. So pretty quick to go over that, but hopefully you got a good understanding of it just from doing it. And that's it. Let me know if you have any questions.